Today we will start the salt analysis of group fifth radical of analysis of group fifth cation. Now, since we will already discuss the cation up to group fourth, so today we will discuss the cation of group fifth. Now, first we will discuss which cations are placed in the group fifth. So, in the group fifth, we are placing the cation that is barium. The cation is barium plus 2, strontium plus 2, comma, calcium plus 2. And the group reagent for the fifth group is disodium hydrogen phosphate, that is Na2HPO4. Now, for the group fifth, we were also applying the flame test. So, we are also using the flame test for investigation of the fifth group radicals. So, in the flame test, uh, uh, in the performance of flame test, first suppose we are having the salt of barium. It may be barium chloride, barium nitrate, or other salt. So, first for the flame test, the salt of the barium is dissolved in the minimum amount of HCl and make a paste of barium salt, and after that this paste apply on the glass rod. Suppose this is a glass rod, so this paste is applied on this glass rod. This is the paste of HCl, paste of barium chloride, which is made up in the HCl. Here is the we are for the formation of paste we are using the only for HCl, not use another acid, since HCl is a low boiling point. Having a low boiling point, it means its in presence of HCl, salt is easily vaporized. And for the flame taste, it should be compulsory that salt is easily vaporized. So, when barium chloride paste apply to this glass rod, and after that this glass rod contact to the burner. So if our salt having barium ion or barium plus 2, then it gives a apple green flame. So apple green flame indicate the presence of barium plus 2. Similarly, if we are having a strontium salt, then same treatment again apply, and this time if salt contain strontium cation, then this strontium cation gives a crimson red color to the flame. So if we are having crimson red color to the flame, then it indicates the presence of strontium plus 2, and if our salt having calcium plus 2 ion, then by the applying of flame test it gives a brick red color. So brick red color, it indicates the calcium plus 2. Brick red color, its flame is very unstable, means looks only for some time, whereas crimson red color and apple green color is comparatively stable and looks for the more times. So by the using of flame test, hello, so by the using of flame test, we can identify this. We can identify fifth group radicals, that is the salt contain maybe barium, strontium, or calcium. Now, except flame test, we are also using chemical test to the investigation of fifth group radical. So, like another group radicals, we are again starting from zero group. So, first we are draw a table, that is experiment, observation, and third is inference. Now the first, start from zero group. First we are taking a salt, small amount of salt, and adding sodium hydroxide solution to the salt. Uh, then the observation is uh, no ammonical smell. So this indicates the absence of zero group. So we can see that zero group is absent. Now we are in the second time we are again taking a salt to the another test tube, and at that time adding dilute HCl to the salt. We are found that a clear solution. Here is the clear solution indicate that uh, here is the first group is absent. First group means Pb plus 2, Hg2 plus mercurous, and Ag plus absent. Now in the third test passed H2S gas through the solution. H2S gas through the solution. Here again clear solution means no PPT. It indicates the absence of second group. So we can say that is second group is absent. Now in the fourth step, boil the solution for removing H2S gas. Since there is no requirement of H2S in group third, so the removal of H2S gas after second group, we are boil the test tube. After boiling the test tube, we are adding NH4Cl in the solid form and NH4OH aqueous in excess. So if we are first adding NH4Cl solid, then adding NH4OH aqueous in excess. So here is again clear solution. Here is the clear solution indicate that in this salt third group is absent. Now in the next step, passing H2S gas to the above test tube. Here is again no PPT, which indicate absence of fourth group. Now for the next investigation, again boil the test tube for removal of the H2S gas, since no requirement of H2S group in the group fifth. So for the investigation of fifth group, first boil the test tube for removal of H2S gas. Boil the test tube for removal of H2S gas, and for the fifth group added NH4OH plus ammonium carbonate, NH4 whole twice CO3. This is the group reagent for the fifth group radicals. Since here is the compulsory that total environment remains basic, so we are again adding NH4OH in excess and ammonium carbonate. It's a group reagent of group fifth. We are having white PPT. It is due to barium carbonate, strontium carbonate, calcium carbonate. So we can say that fifth group is present. Now, the adding of NH4OH and ammonium carbonate. If we are getting a white PPT, then it is a confirmed that the salt contains fifth group. Now, our next step is to finding out that the salt contains what cation. Means maybe barium plus 2, maybe strontium plus 2, or it may be calcium plus 2. But three cations of group fifth, that is barium plus 2, strontium plus 2 and calcium plus 2, all are formed carbonate and color of the carbonate is white. So here is the white PPT which indicate the presence of fifth group. Now for the confirmation of barium, strontium, calcium, we are dissolving this PPT in glacial acetic acid. So applying confirmation test. Dissolve white PPT in glacial acetic acid, that is pure CH3COH. It's a glacial acetic acid. And after this clear solution, means after dissolving the PPT, we are getting a clear solution, and this clear solution divided into three parts. Clear solution divided into three parts. So we are taking one by one part. First, in the first part, adding potassium chromate solution, K2CrO4 solution. We are getting a yellow precipitate of barium chromate. If we are getting a yellow precipitate which is due to the barium chromate, then we can say that the salt contains barium plus 2. It means barium plus 2 is confirmed. But when we are getting in the first part potassium chromate solution, if we are getting a clear solution in place of yellow precipitate, if we are getting a clear solution, then it indicates the barium plus 2 is absent. So barium plus 2 is absent. So here is the both are possibilities. If our salt contains barium plus 2, then we are getting a yellow precipitate of barium plus 2. Then we can say that barium plus 2 is confirmed. And if we are getting a clear solution, then it indicates that in this salt, barium plus 2 is absent. Now, if we are getting a clear solution, then our aim is to finding out the either the salt contain strontium plus 2 or either it contain calcium plus 2. So for finding out the strontium plus 2 and calcium plus 2, we are using the second part. Second part plus. Now we are using the second part, add ammonium sulfate solution. Here is again two possibilities. If we are getting a white precipitate, it is due to the strontium sulfate. So we can say that our salt contains Sr plus 2. It means Sr plus 2 is confirmed. But at that time, if we are getting a clear solution, if in the second part we are adding ammonium sulfate solution, and after adding the ammonium sulfate solution, if we are getting a clear solution, then it indicates that strontium plus 2 is absent. It means the salt absent barium plus 2 as well as Sr plus 2 is absent. Now at that time we are using third part. Now taking the third part and add ammonium oxalate solution, that is NH4 whole twice C2O4 solution. Then we are getting a white PPT of calcium oxalate, that is CaC2O4. This white PPT of calcium oxalate, that is conform Ca plus 2. So, by the following of this scheme, we can identify one by one that our salt contain barium plus 2, strontium plus 2, or it may be calcium plus 2. For that, we are also using flame test that discussed earlier. So, by the using of flame test or chemical test, we are confirming one by one fifth group radicals. Now, we are discussing that uh, in the fifth group radicals, we are performing the fifth group radicals. Then test always perform in the order of barium plus 2 first, then strontium plus 2, then calcium plus 2. Why? Since fifth group radical, that is barium, strontium and calcium, uh, are arranged according to their KSP order. Means minimum KSP for the barium plus 2. After that, the KSP value for the SR plus 2 and the highest KSP value for the Ca plus 2. So in the fifth group radicals, the test performed in the BSC order. The first, we are investigating the barium plus 2, and after that, strontium plus 2, and lastly, the calcium plus 2. Since in the fifth group radicals, when we are dissolving the white PPT, that is due to the carbonate dissolving glacial acetic acid, then it gives a clear solution, and obviously this clear solution is due to the acetate. It means if we are having the barium agar salt, then the clear solution contains barium acetate, that is BaCH3COO whole twice. And if we are containing strontium, then the clear solution is due to the strontium acetate. And if we are having the calcium, then white clear solution is due to the calcium acetate. Now, once we are getting a clear solution, now we don't know that in the clear solution which cation is present. Means the clear solution contain barium plus 2, strontium plus 2 or calcium plus 2. So we are applying the further chemical test, and in the chemical test first we are dividing the clear solution into three parts. So first part we are getting a potassium chromate solution, K2CrO4 solution. So if our salt contains barium plus 2, then we are getting a yellow precipitate of barium chromate, that is BaCr2O4. This is the yellow precipitate. So its yellow precipitate indicates the presence of barium plus 2. Since in the clear solution, that is due to the acetate, when we are adding potassium chromate solution, only barium form precipitate. But at that condition, if our salt contains strontium or calcium, then strontium form after addition of K2CrO4 solution, strontium form strontium chromate, and similarly calcium form calcium chromate solution, calcium chromate. But strontium chromate and calcium chromate both are soluble. Since KSP value of strontium chromate and calcium chromate is comparatively higher than barium chromate, that's why only barium chromate is precipitated due to its lower KSP value. And at that condition, due to higher KSP value, strontium chromate and calcium chromate is not precipitated, although they both are, means strontium and calcium both are converted to their respective chromate. But strontium chromate and calcium chromate both are soluble due to higher Ksp value. Similarly, in the second part, when we are adding sulfate, that is ammonium sulfate. So, if we are already having in the clear solution strontium acetate and we are adding ammonium sulfate solution. So, if we are getting a white precipitate, that is due to the SrSO4, but at that condition, if calcium is present, then it is formed calcium sulfate. But calcium sulfate is soluble and strontium sulfate forms a white PPT. Since if we are compare the Ksp value of strontium and calcium, then strontium having a smaller Ksp value as compared to the calcium. So that's why in this condition only strontium sulfate is precipitated, but calcium sulfate is not precipitated. And at the lastly, when we are adding ammonium oxalate solution to this calcium oxalate solution, then we are getting a white precipitate of calcium oxalate that will conform the calcium plus 2. Now, if we are using the reverse test, it means when we dissolve the white PPT, that is due to the carbonate in glacial acetic acid, then we are getting a acetate, that may be barium acetate, strontium acetate, or maybe calcium acetate. Now, we are dividing the solution into three parts. So, in the first part, if we are adding ammonium sulfate or ammonium oxalate in place of potassium chromate, then what happens? Since Ksp value of the barium is very small, so if we are adding initially ammonium sulfate solution or ammonium oxalate solution, then barium forms 5 ppt. It means due to the lower Ksp value, barium forms precipitate in all of the conditions. Means if we are using potassium chromate solution, then barium forms also LOPPT, and if we are using ammonium sulfate and ammonium oxalate, then barium forms white PPT. So barium forms always PPT by the adding of any solution, since Ksp value of barium is very small. So initially in the first part, if we are adding ammonium sulfate solution, then we are not identify that this salt contains barium plus 2 or strontium plus 2, since both are formed precipitate at this condition. So it's a compulsory that if we are identifying both separately, that is barium plus 2 strontium plus 2, then it's a compulsory that test or reagents adding one by one. So first we are adding potassium chromate solution, since with the potassium chromate solution only barium is precipitated, but at that time strontium is not precipitated. But if we are adding ammonium sulfate solution in place of potassium chromate solution in the first part, then we are getting a white PPT, and the white PPT is due to the both maybe barium sulfate or it may be strontium sulfate. So we can't identify that what white PPT got. So similarly in the second part, if we are adding ammonium oxalate solution in place of ammonium sulfate solution. So by the adding of ammonium oxalate solution, strontium oxalate and calcium oxalate both are from white PPT. Since at that condition barium also form white PPT, means if we are adding ammonium oxalate solution, then all three, that is barium plus 2, strontium plus 2 and calcium plus 2 forms white PPT. So we can't identify that the salt contains barium plus 2, strontium plus 2 or calcium plus 2. So when the investigation of fifth group radicals due to their Ksp value order, we are always finding out in the order of barium plus 2, strontium plus 2 and after that calcium plus 2.